Why is it that pharmaceuticals can't replicate or make adaptogens that operate like this?
Yeah, it's such a good question. So pharmaceutical drugs ideally have one molecular target. They hit one receptor and they hit it really hard and they modulate that one receptor and they do it really well. And that's it. If a drug modulates many receptors, it's considered pharmacologically a dirty drug because you can't track all the downstream effects of 10 receptors being hit at the same time. You can't measure it clearly, and you can't quantify it and replicate it super clearly for amongst the human population. So this is where herbal medicine and pharmaceutical medicines kind of diverge in their theory and philosophy, in that plant medicines have, 10, 20, 30, 50 targets. They're doing so many various things, but they might be doing them very weakly. They're not hitting it super hard and firing really heavily on one pathway, but they're hitting a lot of things and they're doing it relatively gently. So you're having really broad effects, but they're gentler effects for the most part, not always, but for the most part. And so in herbal medicine, we would say that's a good thing when it comes to strengthening the nervous system or mitigating the stress response, because there are so many variables at play in that. It's not, we can modify the effects of just cortisol, but it's more than just cortisol. It's also epinephrine, it's norepinephrine, it's the adjusting the circadian rhythm via the pineal gland, melatonin, and all of these. There's so many various aspects at play, and there are so many different targets that you just can't get, even with a dirty drug, which we would consider, like broad spectrum, you're just not going to get that same, those same far reaching effects. You're going to get more broad effects, but not nearly what a plant medicine will do. And there's just nothing that works very well on that cortisol axis except for synthetic glucocorticoids, so things like prednisone or cortisone or dexamethasone, these synthetic steroids. They act like really strong, potent, agonists of the glucocorticoid receptors, but to antagonize it, there are things like desmopressin, et cetera, to antagonize, but they're very specific, and it is not going to cause systemic benefit. It's for like really significant pathologies, endocrinopathies, we would say. So there's just no real way. Pharmacologists don't want to create these broad spectrum, wide reaching drugs. Again, they really want to create one receptor, hit it heavy, have a very metered effect, and that's it. It just is a totally different model. And there's a time and a place for everything. But when we're talking about something so broad as the nervous system, we have the somatic nervous system, which is like our conscious control muscular nervous system. We have the autonomic nervous system that's branched into the parasympathetic and the sympathetic. And then you have all of the visceral, like you have so many aspects, the neuroendocrine, so many aspects of the nervous system that there's just no way to hit them all with a drug, and again, there's a time and a place for the drugs, but they're not going to do the same thing that an overall tonifier would do. And especially when we take into account the neuroendocrine or the endocrine, the hormonal effects, including the stress hormones, et cetera. We didn't even get into the sex hormones and how stress hormones affect that axis, but that's a huge thing as well.
Yeah, and I think we talked about this once, which is that because it works like this, it's not going so hard on one specific receptor. That's why they don't have these like withdrawal effects that some pharmaceuticals have, right? Yeah,
exactly.
Which is a big deal.
Exactly right. Exactly, and addiction potential, because it's hitting one receptor really heavy over and over and over and over that causes dependency of that pathway. And if you don't have that, even if you're hitting it, but you're hitting it weakly with a bunch of other things, you just do not develop dependencies in the same way that you do with pharmaceuticals. It's just, there's just no way around it.